Good morning, everyone.
Morning, sir.
So today we will start a new topic. It's transportation and assignment problem. Indeed, it is a linear program only, but because of a spatial structure, it is called transportation and assignment problems. We have formulated one of the transportation problem. If you remember when we were doing LP formulation. So to basically understand transportation problem, although I will discuss with you that the name transportation problem has come because of a spatial structure of LP and not because of the domain, but just think of transporting some stuff from one place to another place. So distribution of certain product from several sources. For example, let's say when you order anything from Flipkart, Myntra or Amazon, they have different warehouses, distributed across the country. And from those warehouses, depending on what you have, ordered, they try to deliver it to you. So you can think of you as a customer or the market or demand point that is represented by N here. Warehouses or supply node or the manufacturers are the one where either the product is being manufactured or stored, whatever you say, those are the supply nodes. Then warehouse will have some capacity constraint, so we'll call it as AI, supply at warehouse. Now, in each market or each demand point or each customer area, there will be demand for the product that we will represent by B subscript J as demand at market. J ranges from 1 to N. So there are N markets and M warehouses. Unit cost of transporting from I to J. So suppose if one product is transported from I to J, there is a cost associated with it. Sometimes you will see in some problem, it is also profit associated with it. So if it is cost associated with it, what you would like to do? What would be your objective? Just give me 1 second, guys. Madam. Oh, no problem, no problem. Okay, so I have sent on Tuesday. I have sent the contract agreement, what I have received from TMLL, which we have finalized, and to the Dean's Rec office. Yeah, final document which you have sent them. Yeah, and I also submitted the 2 forms that is for consultancy. So those 2 has also been sent. So I just wanted to confirm if it has. Okay. So if you can, so because I have sent both the consultancy acceptance form and the hard copy for signature. So once it is signed, if you can send me the copies so that I can send it back to TMD. Please look into it, man. Okay. Okay, ma'am. Thank you so much. Okay, madam. Thank you. Sorry, guys. Okay, so suppose if I'm looking at unit cost of transporting from I to J. So suppose think of you as one of the distributor. You have warehouses across the country and you sell only one product and you send it to different customer demands area. And each market has some particular demand, and for sending one unit of a product across CIJ. So suppose you have 4 warehouses. If you are sending it from warehouse 1, it will to customer J, customer 1. Oh, sorry. Yeah, madam. I mean, I have sent it to SRIC office. Yeah. Okay. So sorry, guys. So cost of sending transporting product 1 to customer 1 or customer 2, customer 3 are C11, C12, C13 and so on. So if you want to, what would be your objective if you are trying to transport your stuff products from warehouses to markets? What would be your objective?
Sir, minimize the transportation cost.
So your objective would be minimize the total transportation cost. You agree? Because here we are just looking at unit cost, so we have to minimize the total transportation cost. Now, instead of transportation, suppose the marketing department has converted into profit, you know. So in that case, what you need to do? Maximize the total profit. But generally, when we talk about transportation problem, it is about minimizing the transportation cost. Now, I have written Cij equals to blank here. If suppose particular warehouse cannot supply to a particular market, what should we put cost as if we are trying to minimize the total transportation cost? If a particular warehouse, let's say I want to ensure that Chennai warehouse should not, you know, transport any product to Kashmir market. So how should we ensure that no product is sent from Chennai market to Kashmir Chennai warehouse to Kashmir market? In what case you will not transport anything?
So we can set the cost to 0.
0 or very high cost?
Sir, to
Very high, sir.
Very high.
Very high cost.
Very high.
So cost is so high that the model which you are trying to solve will never put it there. So this transportation problem, if I ask you to formulate it as a linear programming problem, how would you do? So I have given you everything, all the parameters and everything. Tell me what would be your decision variable? I've already given you the decision variable actually. What would be your decision variable? What is the decision question here? So you have M warehouses and you have to supply B subscript J demand, and warehouses as AI supply at each warehouse, and you have to ship it to N market. So what would be your decision variable? Guys, we have done LP formulation long back here. What is your objective? Okay, let's try to understand. What is your objective?
Minimize the total transport cost.
Total transportation cost. How can we calculate the total transportation cost? Okay, let me ask, what is the decision that needs to be taken here? So let me represent it as, suppose you have 1, 2, M warehouses. Each one has a supply of A1, A2, AM. You have to fulfill demand of N markets. So suppose this is 1, 2 markets, 4 and N. So supply and demand, and cost can be from 1 to, if you are supplying and there is a demand side, you have B1 demand, B2 demands and so on. Now, how can you fulfill the demand of, market one, or
Number
where
of
all you can-
units, number of units supplied from ith warehouse to jth market.
right? And you can put the cost here as C11, C21, C31. Similarly, you can link everything. So Xij can simply be quantity shipped from warehouse I to market J, right? So your objective function becomes, give me the objective function equation, G equals to minimize G equals to what it would be?
Summation xij cij.
Cij Xij. Is this correct? What is summation on? Go ahead, try it.
What's that?
What is summation is upon?
The I1 to M and J1 to N.
So double summation. J equals to 1 to M and I equals to 1 to N. Is this correct?
Yes.
That is your total cost now. Now we have to formulate the constraints. So what are the constraints we have? What are the limitations we have? We have ideally two kinds of constraints here. One constraint I have at the supply side and one constraint I have at the demand side. So suppose if I'm looking at the supply side, what should be my constraint? So all the arcs which are coming out of, warehouse one, summation of all the quantities should be less than what?
Supply.
So summation
A1.
Xij should be less than equal to Ai for J ranging from 1 to M for all I. This is called supply constraint. Similarly, summation all the demand of this customer, it can be fulfilled by warehouse 1, warehouse 2, warehouse 3 and so on. So summation I equals to 1 to N Xij should be greater than equal to B subscript I for all j. This is demand constraint. See if I formulated it right or not, whether it is taking care of both the constraints or not. Have I put this formulation correct or not? Just look it very carefully. So first look at the first kind of supply constraint. If J equals to 1, that means I'm supplying from what? You're taking too much time, guys. Is it this difficult?
Sir, it should have been I equal to 1 to
Very good. What it should have been?
I equal to 1 to N. I guess. Like the opposite, just the opposite, whatever you have written.
Why is that?
So because the supply is to one warehouse.
Supply is from one warehouse.
The constraint is on one particular warehouse. J is
So
the jth market. Like
J is the jth market. So it should have been I equals to 1 to M. Is that correct?
yes, sir.
And
And
this should
No,
be
sir.
J.
J equals to 1 to N.
Okay.
That should be J equals to 1 to N, sir.
Okay, let's start again. So I'm looking at I and J. So if I'm looking at Xij, I is the We have defined I as a market or resource, warehouse. So
Warehouse, sir.
we have defined I as the warehouse. So everything coming out of this should sum up to less than equal to AI. So 1 remains constant and J changes. So it should have been from J equals to 1 to N
Yes.
for all. Is this correct, guys?
Yes, sir.
Yes, sir. Yes.
Whatever quantity you are shipping from this warehouse should sum up to less than equal to AI. As similarly here, I equals to 1 to what?
M.
M. So
Sir,
for
in
J
objective
equals to 1
function
to R
also, sir.
I'm sorry.
So for minimize Z
Objective function
also,
also, sir, you have written J equals to 1 to M.
This should have been. Is this correct now? And of course,
Yes,
X
sir.
should be greater than equal to 0. Suppose if you are trying to solve this problem, how would you solve this problem? So how many supply constraints and how many demand constraints you have in totality?
Sir, N and M.
So this is N plus M constraints you have, out of which 1 to M is your less than equal to constraint and N constraints are greater than equal to type. So you have to add surplus variable and artificial variable. Do you agree? So this problem can be made a little more easier if I make total supply equals to total demand. In that case, what will happen? What I'm saying is summation of AI equals to summation of B subscript J. If I do that, this equation will change to Xij should be equals to AI and summation of Xij, one is on J, one is on I, should be equals to J for all I, for all J. So this is called balanced transportation problem. So if we try to solve these problems, if you look at it, if I try to solve this problem using, so this is your formulation, how many artificial variable I need? Yes, guys, how many artificial variable we need to solve this problem? Seems you guys are forgetting very fast. These are equality kind of constraint. How do we solve equality kind of constraint? What
Sir,
are
M
the
plus N.
M plus N artificial variables are required to solve this problem, and that's why it becomes very difficult. But luckily, we have, a simpler way to solve transportation problem. So first thing we need to understand what is transportation table. So I will represent what I have represented here. This is called network representation. Network representation. Now I will show you the tabular representation of the problem. Tabular representation. So in tabular representation, what we do, source, destination. So I'm using source and destination as supply and demand. So I have 1, 2, 3 M sources and N demand points. Okay, in this side, I will write the total supply for each one. For this side, I will write the demand for each node. Okay, and here I will put the cost associated with it. C11, C12, C13, C1N, A1, C21, C22, C23, C2N, A2. Similarly, CM1, CM2, CM3, CMN, AM, and here I will write the demand B1, B2, B3, and Bn. This is called transportation tableau. And we have to ensure that summation B equals to summation A. When it is not true, I will tell you how to deal with this. Okay, but if we want to, solve this problem in the table which I am showing, that I have to ensure that total demand is equals to total supply. Okay, this is called again balanced transportation problem. And all the activities which we'll do in the balanced transportation problem is only true when this is satisfied. And that is why we have a particular structure, which I will discuss shortly. Interestingly, when you put it in this format, suppose 1, 2, 3, M, 1, 2, N, and B1, B2, Bn, A1, A2, An, and if you put the decision variable x11, x12, x1n, x21, xm1, x22, xm2, x2n, xmn. If you sum all these, this should be equals to A1. If you sum all these, this should be equals to A2. Similarly, column wise, if you sum all these, this should be equals to B1, B2, and so on. That is your constraints. Okay. Clear so far, guys?
Yes, sir.
Now let's look at a numerical example. Suppose I have 3 warehouses, W1, W2, W3, and 2 markets, M1 and M2, and I have demand and supply on this side, 80, 215, 100, 108, 102, 68. These are the cost. Whenever table like this is given to you, these are the cost of transporting 1 unit of product. And supply is 1000, 1500, 1200, and demand is in market 1, 2300, in market 2, 1400. First check whether it is a balanced transportation problem or not.
Yes, sir.
Now tell me how many variables, xij's I need to solve this problem.
6.
6. So let me write it as m equals to 3, n equals to 2. So number of variables equals to how much? M into n, right? That is equals to 6 variables. How many equations we have? Number of equations. I mean constraint. How many constraints we have?
5.
M plus n equals to 5 constraints. How many out of these 6, how many we can, assign? You have 6 variable and 5 constraints. So how many basic variables are possible? How do we decide number of basic variables? Guys, I have 6 variables and 5 equations. For how many variables I can solve these equations?
5.
5. M plus n minus 1, which is equals to 5. Is this correct?
Yes, sir.
But m plus n minus 1 is 4, right?
Yes, sir. M into n minus 1. Sorry.
No, it is m plus n minus 1. So there are although 5 equations, but I can only assign 4 as a basic variable. Fifth one will be 0. Can you tell me why? So basic variable in BF solution, basic feasible solution, should be equals to number of constraints. But I'm saying number of variables that can take positive value is limited to m plus n minus 1. Why is that? Why I'm not able to use all the 5 equations? Why I'm only able to use 5 minus 1, 4 equations to solve? What is the double summation of xij equals to? If I add up all the decision variables, this will be equals to what? AI? All the supply,
Yes,
because
sir.
it's a balanced transportation problem. If I add up all the, it is also equals to the total demand because it is a balanced transportation problem. What this will lead to? I have 5 equations, but one of them become redundant. Do you agree? One of them become redundant. To better understand, let's associate variables with this one here: x11, x12, x21, x22, x31, x32. Let me write the x11 plus x12 equals to 1000. All the supply one I am writing first. x21 plus x22 equals to 1500. x31 plus x32 equals to 1200. These are your supply constraints I have. Now column wise, if I add it up, x11 plus x21 plus x31 equals to 2300 and x12 plus x22 plus x32 equals to 1400. Is the constraint, I have written the constraint right for this problem or not? Just look at it. So these are your supply constraints and these are your demand constraints. Is this correct?
Yes, sir.
If you add up all these constraints, what you will see that one of the constraints is becoming redundant. So although I have 5 constraints, but I can find a solution only with 4 because fifth one is redundant. If simply just add up any of them. Just a second. How many? Okay. Oh, okay. Yeah. Yeah. Okay. Yeah. Okay, ma'am. I will do the needful once. Please let me know when to come. Okay. Okay, okay, thank you, madam. Okay, thank you so much. Okay, guys, are you able to follow why we have one less constraint to solve this problem? Is it clear?
Yes, sir.
What is happening? That is related to rank of a matrix. If you look at the A matrix here, it has one less rank because any one of the constraints can be written as, linear combination of other 4 constraints. And that is the reason it is your one less constraint. So whenever you are solving this problem, keep in mind that only m plus n minus 1 variables or cells will have positive value, will have greater than equal to 0 value. The rest of them will be not assigned. So whenever you are solving, this is a kind of a sanity check. If you are assigning more than this much, that means you are making a mistake. Okay.
Sir, but this is true only for balance.
Yeah, this is true for only for balanced transportation problem. Because if it is unbalanced, I cannot guarantee this part, right? And because of this spatial structure, these problems are called transportation problem, not because it has to do with transporting the goods. I will show you one example from production planning where we will formulate it as a transportation problem instead of a regular linear programming problem. Because of this structure, this is called transportation problem. So this is about how we formulate and all that. Now coming to solving transportation problems. Any questions so far, guys? So suppose you have already seen, if you want to just give me 1 second, I need some water. So we have already seen there m plus n minus 1 equations instead of m plus n equations to solve the problem. So if we go by our regular simplex, we have to use artificial variables to solve this problem. You agree? So let's not talk about artificial variable technique. Suppose if I want to solve this problem and I just want an initial basic feasible solution. Forget about anything. I just want initial basic feasible solution and I don't want to use any artificial variable technique. So there are methods. These are called heuristic. Heuristic are the method which exploit the structure of a particular problem and try to find a solution. So the way we solve transportation problem is first we find initial VF solution using heuristics. And then there is something called transportation simplex, not like simplex we have seen earlier, but it has exactly same kind of analogy. I will explain how it is simplex. later when I will look at the transportation simplex. So this heuristic we use to solve, find the initial basic feasible solution. And then on that initial basic feasible solution, we run the transportation heuristic. For the heuristic, we have three heuristic which we can use. First one is called northwest corner method. Second heuristic is least cost method. And third heuristic is Vogel's approximation method. And as I have written 1, 2, 3, actually each one of them give you a better solution as I move from northwest to Vogel's. So now we will see each of the heuristic to find initial basic feasible solution. So let's first look at the northwest corner method. Northwest corner method. So first we need to put it in a table. So in this case, I have 4 markets, 1, 2, 3, and 4. Try to make big tables because we need to write many things in here. And 3 source, 1, 2, 3. Make a table first. Okay, write the supplies on this side. So we have supply 15, 25, and 10, and demands here 5, 15, 15, and 15. Then write all the cost, unit cost at this corner. Okay. So write all the costs in the right hand top corner and leave this area empty because we'll put the value of the xij's here. Okay, now let's start solving this problem. So this is my northwest corner. So what we'll do, we'll start from north and we'll try to go to west. So let's look at this cell. What is the supply for in this cell? What is the maximum supply possible? What is the maximum I can supply from this node? 15? Is this correct? I do not know what your silence means. So I have maximum 15 I can supply from 1 to 1, but I have demand only 5. So how much I should allocate to this corner, this cell? 15, right?
No, sir.
How much you should put?
5.
5. Very good. So we will allocate 5 here. Why? Although from warehouse 1 I can supply 15, but demand for this market is only 5. So I will only allocate 5 here. Once you have allocated it, you have to do one more thing. You have to cut this 5 and you have to cut this row because the demand of this row has been satisfied, and adjust the supply here, which was 15. Now adjust it to 10. Is this step clear to all of you? Any questions? How we have assigned 5 units from warehouse 1 to market 1. Do you have any questions, or should I stop recording the classes so that you have to pay attention in the class itself?
No question, sir.
Okay, so now we'll move to the, since I still have 10 units left in supply source 1, I will move in this direction. I will put an arrow here. Now I am in how much I can supply from warehouse 1 to market 2. Let's look at it. What is the demand? 15.
Yes, sir.
What is the supply? 10. How much maximum I can allot to 2? 1 to 10. Once I have done this, put it 0. This row has been satisfied. Cross it. Also change it to, you have 5 demand left for this one. So I still need to fulfill 5 demand here. Now, can I proceed in this direction any further?
No.
No, sir.
What we will do? Now we will move in this direction. So now we have in warehouse 2 and market 2. The warehouse capacity is 25, but I only need 5 here, right? So I will fulfill this demand with 5 units here and cross this one and also cross this column altogether because demand has been fulfilled. Here I will cross and 5 has been, so I have 20 left. Good so far?
Yes, sir.
Now let's move in the northwest direction. Here I will come. My demand is 15. I can fulfill all the demand here. So I will set it to 0. I will cross this column. I will assign 15 here. I will cross this one and I will have 5 left here. Again, supply is there, so I will move in this direction. Here demand is 15 and I have only 5 left here, so I will assign all these 5 here. I will reset it to 0. I will cross this row because this has been satisfied. This has also been satisfied. Now there is only 1 left and this will be, the demand is 10. Okay, I have forgotten to. I can fulfill all the demand here. So I can write x11 equals to 5, x12 equals to 10, x22 equals to 5, x23 equals to 15, x24 equals to 5, and x34 equals to 10. Okay, all other xij's equals to 0. So once I have set all these things, this will become 0. This will become, I can cross all the rows and columns. Now here keep also one thing in mind. If row and column being satisfied at the same times, if row and column is being satisfied at the same time, cross out the row. Okay, always cross out the row if row and column being satisfied at the same time in this case. Okay, so how many variables for this problem? So your m was 3 and n was 4. So how many variables we have? 12 variables we had, and number of constraints were equals to 7. If m plus n equals to 7, how much Maximum allocation, how many variables can be assigned greater than equal to 0?
6.
M plus n minus 1 equals to 6. 1, 2, 3, 4, 5, 6. Is this correct?
Yes, sir.
Yes, sir.
How can we ensure that it is a basic? This is actually initial feasible solution. Is it a basic feasible solution or not? I'm not saying whether it is optimal or not, whether it is a basic feasible
Yes,
solution or
it,
not.
it is.
Can you please repeat? I cannot hear you.
It is basic feasible solution.
Devasys, your voice is not clear, buddy.
It is basic feasible solution.
It is a basic feasible solution. First of all, I have made this m plus n minus 1 criteria. All xij's are greater than equal to 0. And also, if you look it from row side, 5 plus 10 equals to 15 is being satisfied. 5 plus 15 plus 5, 25 is being satisfied. 10 equals to 10 is being satisfied. In this case, column wise, 5 is being satisfied. 10 plus 5, 15 is satisfied. 15 is satisfied. 5 plus 10, 15 is satisfied. So indeed, it is a initial basic feasible solution. So this is what heuristic is. Heuristic is what it is doing. No matter what kind of balanced transportation problem you bring, you can always solve it using this heuristic northwest corner method. So heuristics are special solving algorithm, solving techniques which is problem specific. You can only solve transportation problem with this heuristic, not any other problem. Okay. Now, can you find me the G value for this problem? How much G value is? Give me the G value for this allocation. Excuse me. So all you need to do is 5 into 10 plus 10 into 2 plus 5 into 7 plus 15 into 9 plus 20 into 5 plus 10 into 18. Give me how much G values you get.
Sir, 420. 420.
420 or 520? $50 plus 20, 70, 70 plus 35, 105, 105 plus 15 into 9 is how much? 135 now. 105, 240, 240 into 100 is 340, 340 plus 180.
It's 520.
It is 520.
Yes, 520.
Do you like the method? For initial basic feasible solution, no slack variable, nothing, right? I want you to criticize this method based on the quality of solution which you have got, G equals to 520. Criticize this method. What is the wrong is being done here? Not wrong. I mean, there can be a better way to do it. This is the most naive way to do this thing.
So there are some in row 3 we are supplying 10 products of cost 18.
Very good.
It could have been better. Like we would have used.
So this method has not taken into account anything about the cost. It had just simply assigned whatever possible. I could have, instead of, as you have very well pointed out, instead of using this 18, why couldn't we have used this 4 and try to supply something from here? Similarly, here, if you look at it, there are other costs which can be used, like instead of supplying from 1 to 1, I could have supplied from 1 to 2 at a lower cost, a lot of values, right? So you understand this is not the most brilliant method to allocate something. Even if after this, if you apply the transportation simplex, what it will do is, see, at the end of the day, you're solving a LP only, keep in mind. It will take more iterations to reach to the optimal solution. Agree? Because you are starting with an inferior solution. So the next method tries to take care of that. That is your least cost method. So we'll take a small break here. We'll come back at 12:05. It's 11:55 in my watch, and we'll learn about least cost method. So I hope you guys are back. So I have created a new transportation tableau. Now in this one, we'll use the least cost method. So what we need to look at from all the not crossed cell and row and column, look at which one is the minimum cost in the whole table. Which one is the minimum cost in the complete table, because none of them are row and column crossed. 2.
2, yes.
Okay, so let's come at 2. How much we can allocate?
15. No, yeah, 15.
Complete 15 can be allocated here. After that, I will make cross this to 0 and cross this to 0. Okay. So when both of them are being satisfied simultaneously, you need to cross one of them, not both of them simultaneously. So generally we cross the demand columns. Okay, because all the demand in this column has been satisfied. I will only cross the demand column out of these two, although both of them have been satisfied. You will realize soon why I have done so, because what I'm saying that I do not have demand in this market anymore. So I have taken care of this column. Now from uncovered rows and columns, tell me which one is the minimum cost now?
4.
4. So I will go to here and see how much I can allocate. So maximum how much I can allocate to this cell?
10. 5, yes, yeah,
5.
demand is 5.
So I will cross this. I will make it 5. And I will cross this column as well. Okay. Now from uncovered cells, tell me which one is the minimum cost now? 9.
Yes.
So here my supply is 25 and demand is 15. So I will satisfy all the demand as 15 and I will cross this to 10. I will cross this to 0 and cross this column. Good so far. Now amongst the uncrossed column or rows, what is the minimum cost we have? Yes, Baba.
18, sir. Like,
No. See,
11. But
this row is not crossed. So now I will go to 11.
11.
How much maximum I can allocate here? 0. Now I can cross this row. Sorry, cross this row. Yes. Now from uncovered row and column, minimum is 18. So I will go here. Maximum I can allocate is 5. So I will allocate 5 here and I will cross this. Sorry, I will cross this row. Okay. And finally, whatever is left, I will go there and allocate 0, 0, here, 10. Now I can cross both rows and columns. Now look at how many allocation we have done. So x12 equals to 15, x14 equals to 0, x23 equals to 15, x24 equals to 10, x34 equals to 5, and x44 equals to 5. All other xij equals to 0. Tell me how many allocations we have done. Count it. 6. So this is the importance of which column or row to cross. This 0 is actually important here. because this is telling me because of this only I'm able to make 6 basic variables out of 7 equations. So when you are crossing, always keep in mind among the demand and the supply, if both are being satisfied simultaneously, cross the demand column because I do not need to supply anything more here. The idea is the one where demand is left but supply is 0. That means market is wanting supply from you. You are not able to supply. That's why I have put 0 here. If you look it from an initial basic feasible solution, can you tell me the nature of this solution? From initial basic feasible solution point of view, what is the nature of this problem solution? When a basic variable becomes equal to 0, what do we call it? You are going forward, but forgetting all the previous syllabus. A degenerate solution. Your basic variable, one of the basic variable has become 0. You remember that?
Yes, sir.
Now, tell me what is the G value here? What is the G value here? Just multiply corresponding numbers and tell me and add it up. Some product. How much?
470.
How much?
475.
475. So definitely better than Northwest. Still, I want you to criticize this method. Although it is better than Northwest, but I want you to criticize this method based on something. Anything you can think of? So the criticism of this method is, although it is better than Northwest, it takes into account the cost, but it takes into the account only the current cost, not the future cost. Do you understand this statement? It only takes into account the current cost, which the current iteration. If I say that the first time wherever you are putting, it only cares about which one is the minimum at that time present. Not if I can do a trade-off that I give small amount here, but later I can give a bigger amount to other costs. So that is being not taken care of, and that's why the third method takes care of that. It is called Vogel's approximation method. It is one of the finest heuristic for solving transportation problem. Many a times it gives you optimal solution directly. So although I'm trying to find the initial basic feasible solution, but many a times it gives you the optimal solution itself. So let's look at this method, how it works. So as you have expected, it will be little involved because it is the best method available. So whenever you are trying to make solve a problem using Vogel's approximation method, keep a lot of space on your right and the bottom. 1, 2, 3, 1, 2, 3, 4, 15, 25 and 10, 5, 15, 15 and 15. Okay. Now let me put the cost 10, 2, 20, 11, 12, 7, 9 and 20, 4, 14, 16 and 18. Let's start with this method. So in this method, what we do, we find the row penalty in every iteration. So I will write row penalty here. Row penalty. So row, let me use another color. Eraser sometimes make me crazy. Doesn't work. Row penalty, and this is column penalty. So let's see how do we calculate row penalty and column penalty. So the idea is for each row and column, determine a penalty measure by subtracting smallest unit cost from the next smallest unit cost. So what is the smallest unit cost here? 2. What is the next smallest unit cost? 10. So we'll write 10 minus 2 equals to 8. Similarly here, 9 minus 7 equals to 2 and 14 minus 4 equals to 10. Similarly, we'll calculate the column ones. 10 minus 4 equals to 6. 7 minus 2 equals to 5. 16 minus 9 equals to 7. And 18 minus 11 equals to 7. Is the row penalty and column penalty clear, guys? How we calculated row penalty and column penalty?
Yes, sir.
Now, among these, identify the largest penalty among row and column. So which one is the largest penalty, guys?
10 in row and
So column 3, row 3 has the largest penalty of 10. So once we have find out the largest penalty column, row or column, we look for the smallest cost in that row or column. So what is the smallest cost in this row or column?
4.
4. Let's allocate as much possible. Since demand is only 5, I cannot allocate more than that. So I will put 0 here and 5 is still left here. I will cross this column because demand for this column has been satisfied. Now I will not take into account this column for column penalty. Now let's go to the next one. So again, we have to calculate the row penalty. So tell me which one is the what is the smallest cost and next smallest cost, removing the column or row which has been crossed out. So what is the smallest cost here? 2. What is the next smallest cost?
11.
So 11 minus 2 equals to 9. Similarly, 9 minus 7 equals to 2. 16 minus 14 equals to 2. Column penalty. This one we will leave it as it is because this column cannot be considered for calculating the penalty. Here it will be copied just because these columns are as it is. 16 minus 9 equals to 7 and 18 minus 11 equals to 7. So which one is the highest penalty we have right now? Row 1. Fine. So again, look at the smallest cost element in this row, which is 2. We'll try to allocate as much as possible. So 15 and 15. So let me cross out this 15 to 0. Let me cross out this 15 to 0. Allocate 15 here. Cross out this column. Good so far?
Yes, sir.
Okay. Now finally, third time row penalty. So 20 minus 11 equals to 9. 20 minus 9 equals to 11. 18 minus 16 equals to how much? 2. Column penalty. Dash. 16 minus 9 equals to 7. 18 minus 11 equals to 7. The biggest penalty I have is 11. So I will go to this row. So once I reach this row, which one is the smallest cost from uncrossed row or column?
9.
9. So we'll reach to 9 and allocate as much possible. So I have 15 here. So I will equate it to 0. Here I'm left with 10. I will allocate 15. So 15 here. See, I was using different color. 15, 15, and I will cross out this column. Good so far? Now, only one row or one column remains the uncrossed out. We use least cost method for that row or column, whichever it is. So in our case, it is column. So let's look at column number 4. Which one is the least cost here? 11. How much I can allocate maximum? 0. Right? Let's cross out this row now. Next, smallest cost is 18. How much we can allocate here? 5. So 5 becomes 0. This becomes 10. Allocate 5. Cross out this row. And finally, whatever is left, you can put it here, which is equals to 10. Cross out everything. Is the method clear, guys?
Yes, sir.
Yes. Any questions? So again, in this case also you will see G equals to 475 because of the problem, the kind of problem it is, least cost and Vogel's approximation method is giving you the same solution. Okay, so good so far. So we have learned 3 methods to find the initial basic feasible solution. Now, these are good initial basic feasible solution, but we do not know whether they are optimal or not optimal. So next what we will learn is how to find whether we have an optimal solution or not. Hello?
Yeah, hello.
Yes.
Yes, sir. Good afternoon, sir.
I'm in a class, I will call you later. So to find the optimal solution, we use, it is called method of multipliers. I will show you later that it is nothing but the dual solution. The method of multipliers, UV method. Okay, and this method we will learn to show that whether so whatever you have found so far is just the initial basic feasible solution. We still need to ascertain whether we have reached the optimal solution or not. So what you need to do, take any of the initial basic feasible solution which you have found using any of these methods. So I will start with the northwest because it was the most inferior solution and try to show you. You can take any one of them. If a question is not specifically asking you how to solve for initial basic feasible solution, always use VAM. VAM is Vogel's approximation method, because that will reduce the number of iterations to reach to the optimal solution. If I have specifically mentioned that find the initial basic feasible solution using this particular method and then use the method of multipliers to find the solution, then you have to use. The reason I'm using northwest corner method because we have most inferior solution. So I will be able to show you the some iterations and how to do it. So the method, the way it works is again, try to make bigger table here because a lot of cell thing we need to do. Okay, 1, 2, 1, 2, 3. Okay, so first write down all the costs 10, 2, 20, 11, 12, 7, 9, 20, 4, 14, 16 and 18. I will populate it with the solution I have found for northwest. So 5 here, 10 here, 5, 15, 5 and 10. So this is the northwest solution which we have found, and now I will try to see whether it is a optimal solution or not. So some of the steps I'm writing here for you to remember. So before that, you assign U1, U2, U3. So let me cite it. U1, U2, U3. So U's for your rows and V's for your columns. V1, V2, V3 and V4. Okay. So for each basic variable Xij, calculate Cij equals to Ui plus Vj. First step. For each non-basic variable Xij, calculate Cij Cij Ui plus Vj. Ui plus Vj minus Cij. Initialize with U1 equals to 0. Okay, so let's start. I put U1 equals to 0. So for each basic variable, I'm going to ensure Cij equals to Ui plus Vj, and for each non-basic variable, I will calculate Ui plus Vj minus Cij, and I will initialize with U1 equals to 0. So if U1 equals to 0, what would V1 becomes based on the basic variable? So just keep in mind, these are your basic variables. Okay, the one which has the assignment, the one which are blank are your non-basic variable. So let's start putting for. So what is Vj equals to, guys? If U1 I'm allocating it to 0, what does the Vj becomes based on this basic variable?
5, 10.
10.
10.
Cij, right? Not the. So V1 becomes 10. Similarly, what would V2 will become?
2.
Okay, no further we need to go. So let's come here. What would be U2 will be equals to? So V2 is 2, C2 is 7. So 7 minus 2 equals to 5. Agree?
Yes, sir.
Similarly, now you can calculate V3, which is 9 minus 5, 4, and V4, 20 minus 5, 15. Now you have 15. Now you can calculate your U3. equals to 18 minus 15 equals to 3. Just look at if you have understood the calculation. Give me a second. Is the calculation of UI and VJs clear, guys? Any questions?
No, sir.
Okay, now let's take care of the non-basic variable. Here we do not have an equality, or what we have is we will calculate a number UI plus VJ minus Cij, and we'll store that value here. So let's start with the cell 1, 3. U1 equals to 0, V3 equals to 4, and Cij equals to 20. So how much this value will become?
Minus 16.
Minus 16. So 0 plus 4 minus 20 minus 16. Similarly, you can calculate other values. 4, 3, 9, minus 9, and minus 9. Good so far? So for using the basic variables, we have found the UI and VJs. Using the non-basic variable, we have found the UI plus VJ minus Cij. Now we'll do the optimality check. So what optimality checks tells you, for non-basic variable coefficients which you have found, UI plus VJ minus Cij should be all negative. If all of them are negative, stop, you are at the optimality. Are we at the optimality? Is the solution optimal based on the optimality check?
No.
No, sir.
We have your 9, 3, and 4 as positive numbers. Until unless they becomes negative, we cannot say we have reached the optimality. Interestingly, what you are seeing here is nothing but the gth row or gth equation. Suppose these are my x11, x12, x34. Okay, and this is my RHS. So for basic variable, this will be 0. For basic variable, your 0th row coefficient is 0 or not?
Zero.
0 only. You can check UI plus VJ minus Cij if you do for basic variable 10 minus 10 0, 2 minus 2 0. And for non-basic variable, you will have some numbers. Since this is a minimization problem, we are looking at all the coefficients to become negative. Had this been a maximization problem, we should have looked for every value greater than or equal to 0. So it is actually a simplex only, but in a tabular form. So how to decide the entering basic variable? That is the next question. So entering basic variable, we decide based on choose highest positive value of non-basic variable UI plus VJ minus Cij. I have already shown this is nothing but 0th row. It's also called reduced cost. I will define it later. After you have realized which one will enter, so in our case, which one will enter? Which one is the entering basic way? Which one? This guy? Highest positive value. So x31 will enter the basis. So x31 is the entering basic variable. Now, to solve for the how to solve it, we construct a loop. Very interesting concept actually. How a spatial structure has been exploited to make an algorithm. So you have to construct a loop. The rules are start and ends at entering basic variable cell. So in our case, it is x31. Loop consists of connected horizontal and vertical segments only. No diagonals. Corner element should be a basic variable. Exactly one loop exists. Okay, so exactly one loop exists. These are the rules. First, it starts and ends at the entering basic variable. Loop consists of connected horizontal and vertical segments only. Corner elements should be basic variable. Exactly one loop exists. Let's try to create this loop here. So where do we start? Here. X3, one cell. Is this correct? Is this correct or not, right?
Yes, sir.
Now let's start moving. Can I stop here? Look at the rules in also. Can I stop? Can I make a corner element a non-basic variable? It should be always a basic variable. I cannot stop here. It is a non-basic variable. So I can only stop at a basic variable. That is my corner. So I will stop at the x34. Then it says vertical and a horizontal line. So I can go here. This is also a corner point and also a basic variable. I can stop here, but it would be difficult to go above it because it is non-basic variable. So rather I will stop at this basic variable. Then I will go up. Then I will go here and I will come back. See if you can create any other loop other than this. Just try to visualize. So I have taken care of all the rules. It starts at the entering basic variable, which is x31. All the corner points are your basic variable, and there are only horizontal and vertical lines, no diagonal lines. Now check if you can create any other loop here or not. Is it possible?
No.
Okay. Now, since x31 is entering the basis, what is the value of x31 right now? What is the value of x31 right now in the current solution?
9.
Huh? Is this the value of x31 or it is the gth row coefficient 9?
It is 0.
It is 0. So let's say its value increases from 0 to theta when it enters. So let me use another thing. I'm increasing its value from 0 to theta. if I'm increasing its value from 0 to theta and supply is limited, from where I have to get that theta? See if I have done right or not. See, my supplies are constrained. This is 15, 15 and 10, and this is 5, 15, 15 and 15, right? So if I'm increasing this value from 0 to theta, I have to subtract it from somewhere. Agree? So that sum of 10 minus theta plus theta should be equals to 10. Does that make sense, guys? So it is the same concept as minimum ratio. Someone is entering the basis, so its value is being increased from 0 to a particular value. Let's say that value is theta. Now when I increase it to theta, someone has to come down first to 0, then only this can enter and someone will leave the basis. Does that make sense?
Yes, sir.
But we have constraints like sum of this whatever basic variables should be less than equal should be equals to 10. So the only place from where I can deduct this theta is this guy. Now when I go up, if I look at this column, sum of 5 plus theta and 10 minus theta should be equals to 15. So I have to add theta here. Since I'm adding theta here, I have to subtract from here so that the sum remains 15. Similarly, if I'm subtracting here, I have to add it with someone so the sum remains 15 here. And similarly, 5 minus theta and 5 plus theta, theta equals to 5. Does that make sense? Okay, I will try to explain it with the graph. Suppose 1, 2, 3. 1, 2, 3, 4. I'm just only putting the basic variables links, nothing else. So right now, I'm not putting the cost here, but the basic variables values. Right now, I'm sending from x11 equals to 5, x12 equals to 10. Similarly, x22 equals to 5, 15 and 5, and x34 is right now 10. Now, the entering basic variable is x31. I am putting it as a dash right now. This is the entering basic variable. Total I have here is 10. Right now, I have to give theta to this guy. You agree? When its value increases from 0 to some number theta. So this is the theta. Now I have to adjust this theta from everyone. So 3 is now sending to 1 and 4. So that theta should be subtracted from here or not? Ma'am, I'm in a class. Can I call you in 5 after the class? Okay. So if theta, see, sum of these two, whatever I'm sending from warehouse 3 should be adding up to 10 because that is the supply. So if I'm increasing this value x31 from 0 to theta, I have to subtract it from x34. Does that make sense? If you don't tell me, how would I know whether you're following or not?
Yes.
So I have subtracted theta, let's say theta equals to 2. I have subtracted 2 and make this x31 as theta equals to 2. Now I have theta more here, but I have limited demand. So I have to subtract something from here so that the sum of this 5 minus theta and theta becomes equals to 5, the demand for that commodity. Since I'm sending theta less to this guy, I will add that theta to this guy and send it here. Again, this is theta more, so it needs to subtract from somewhere. So this is how we are trying to add and subtract all these values based on theta. Now, is it clear how I'm adding and subtracting thetas? Please confirm. If you have a doubt, tell me so that I try to explain with some other way. If you do not, then I will proceed. So I take it as a yes and I'm going ahead. So okay, now this theta, the value of x31, which was a non-basic variable, now it is entering the basis with a value of theta. What I need to ensure about these numbers, theta, 10 minus theta, 5 plus theta, 5 minus theta, 10 plus theta, and 5 minus theta to remain feasible. What I need to ensure? To remain feasible, what I need to ensure? Think of it as a minimum ratio test. What we used to ensure when something was entering the basis.
Coefficient, it should be
Sorry?
0. Its coefficient is 1 and we make it a 0.
That is what we look in the minimum ratio, guys. We have to ensure that whatever basic variable there should be greater than or equal to 0. That's the only feasibility condition we have. Do you agree? Whatever assignment I do should be greater than or equal to 0. Makes sense?
Yes, sir.
Yes.
So conditions we have here is. Put it all the right upon. Okay. So what the condition we have here is simply theta should be greater than or equal to 0. 10 minus theta should be greater than or equal to 0. 5 plus theta should be greater than or equal to 0. What was the next? 5 minus theta should be greater than or equal to 0. 10 plus theta should be greater than or equal to 0. All cells should be greater than or equal to 0. Other constraint we have already taken care of when we are assigning this theta. So we don't need to worry about these guys, 5 plus theta and 10 plus theta, because theta is greater than 0, they will be greater than or equal to 0. We just need to worry about these. So theta should be greater than or equal to 0, 10 minus theta should be greater than or equal to 0, and 5 minus theta should be greater than or equal to 0. If these are the three conditions, what theta should be equals to?
Less than 5.
Huh?
Less than 5. Less than 5.
Why not equals to 5?
Yes, sir.
Yes.
Equal, less than equals to.
What we need to ensure that when this non-basic variable x31 is rising from 0 to a value theta equals to 5, we have to check which one is the leaving basic variable amongst them. Which one will become 0 when I increase. So this will not become 0. This will become 0 when I increase from 0 to 5. So we will draw the next table. Okay. Again, all the numbers 10, 2, 20, 11, 12, 7, 9, 20, 4, 14, 16, and 18. So x31 was entering with a value of, let me also write the numbers here so that you see that this is being satisfied all the time. So theta comes out to be 5. We have 10 minus theta here, so this will become 5. We had 10 plus, sorry. We had 10 minus theta here, so this will become 5. We had 5 plus theta here, so this will become 10. This was 5 minus theta. I will assign it to equals to 0. And then I have 10 plus theta, so this will become 15. So now you will see that there were two places where it was 5 minus theta. So there was a tie. both of them are becoming non-basic with a value of 0. So arbitrarily, I have chosen x11 to leave the basis, and I have kept x22 as a basic variable and assigned a value of 0. I forget this 15 is there. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Is it clear? So x11 left the basis with becoming 5 minus theta equals to 0. Other 5 minus theta which was becoming 0, I kept it as a basic variable because there was a tie. Arbitrarily, I cancelled that tie, and we have said that x11 is the leaving basic variable. Good so far? Any questions?
No questions.
Yeah?
No questions.
Okay, good. Now we need to check whether it is a optimal solution or not. How do we check that? How do we check whether it is an optimal solution or not? Huh?
Coefficient should be negative.
Okay. So find the coefficient to be negative. What we need to do? Okay. Also, G here will come out to be 475. The new G based on new allocation. Let me put G equals to 475. You can put these numbers. So from 520, we started with G equals to 520, the northwest corner solution. Now we have came down to G equals to 475. Again, we have to assign U1, U2, U3, V1, V2, V3, and V4. Initialize U1 with 0. Find me all the U1, U2, U3, V1, V2, V3, V4. Go ahead, find all these numbers. Tell me what these numbers are. Same rule for basic variable, Ui plus Vj equals to Cij. For non-basic variable, you have to find the 0th row coefficient as Ui plus Vj minus Cij. So find all the Ui, all Vjs, and all the corner element for the non-basic variable. What is V1 equals to?
One.
So for this one, you have to start from here. U1 equals to 0. This is a basic variable. So you can start with finding V2. V2 equals to 2 plus 0, 2. Now come down here. Here you can find U2 equals to 5. Now once you have found U2 equals to 5, then try to go to find V3 equals to 4 and V4 equals to 15. Once you have found these numbers, you can from here you can find U3 equals to 3, then V1 becomes equals to 2. Fair enough. Now you can find all the numbers minus 9, minus 16, 4, minus 6, minus 9, and minus 9. Are we at the optimality, guys?
Yes.
How do you decide optimality?
Coefficients of all non-basic variables should be negative.
Or is it true? All the variables have become negative? Coefficient has become negative?
No.
Is this a negative number?
No.
So which one will enter the basis now? Which variable will enter the basis?
X14.
X14, assign theta, 15 minus theta, 0 plus theta, 10 plus theta. See if any other loop is possible or not. Is any other loop possible? So now you have in iteration 2 entering basic variable is x14. No other loop will be possible. Only one loop can be constructed. Now we have to ensure that 15 minus theta is greater than equal to 0 because all xij's should be greater than equal to 0. Other than that, everything is positive. So theta equals to how much? What should theta be equals to? Am I missing something? Theta minus 15 minus theta. Okay, I am doing a mistake here. It should be 10 minus theta because I have added theta here. So I have two conditions. 10 minus theta should be greater than 0 and 15 minus theta is greater than 0. What should theta be equals to now?
10.
10. So let's make new allocation table. 1, 2, 3, 1, 2. Numbers are 10, 2, 20, 11, 12, 7, 9, 20, 4, 14, 16, and 18. Now since my new theta equals to 10, 15 minus 10 is 5, 0 plus 10 is 10, 15 as it is from earlier, this becomes 0. So x24 is the leaving basic variable. So I should not put 0 here because it is a non-basic variable now. And other assignments as it is where we have not touched anything. So 1, 2, 3, 4, 5, 6. Now we need to check whether it is an optimal solution or not. So u1 equals to u2 equals to u3 equals to v1 equals to v2 equals to v3 equals to v4 equals to. Go ahead, find v1, v2, v3, v4 and coefficient of the 0th row or reduced cost. I will tell you what reduced cost is next class. Go ahead, find it, give me what values you get. You have exactly 1 minute. Simple calculations. Start with u1 equals to 0. u2 becomes 2. Come down. 7 minus 2, 5. Go this side. 9 minus 5, 4. Okay. 0 is this one. So this has to be v4 equals to 11. 11. Then 18 minus 11 equals to 7. These numbers you will get minus 13, minus 16, minus 10, minus 4, minus 5, and minus 5. You can just check these numbers. Now, can you tell me whether you have reached the optimal solution or not?
Yes, you have.
Here you will find G equals to 435. Had you been using Vogel's or least cost method, you only would have required only one iteration, because you have used a inferior method, northwest method. That's why you had to do 2 iterations. Otherwise, you could have found this 435 in just 1 iteration had you used initial basic feasible solution from the least cost or Vogel's approximation method. Okay, so I want you to just go through it. Just make sure that you have understood the method, and tomorrow I will explain the mathematics behind this method and some special cases when it is an unbalanced transportation problem, when there are multiple optimal solution. All those cases I will, not tomorrow, next class on Wednesday. So if you have any questions, I can try to clarify right now, or you go over it and we can discuss it on the Monday.
Hello, sir.
Yes.
So in the above iteration,
Yeah.
above than that. So the row 2 and column 2 also became 0 here. Why we didn't consider that?
Which one, row? Can you repeat? Others?
This one. So 1501.
Can you tell me the row cell number so that I can understand?
Second column, second row.
Second column, second row. What it has become?
Yes, sir. So why we don't consider that as living?
Okay. So we need to go up here. So 2 of them were becoming 0. Right?
Yes, sir.
What is
Yes,
this
sir.
type called? This is exactly simplex. Only thing is the tabular representation I am doing. When there is a tie between leaving basic variable, what do we do?
Arbitrary.
Arbitrarily. In fact, that's a good thing for you to try. Instead of making this as a leaving basic variable, you make this leaving basic variable, assign it to 0 and see what happens. Clear?
Yes, sir. So now I got it, sir.
So it is just entering and leaving basic variable ties we are talking about and nothing else. And tomorrow I will show you it is nothing. This UI and VJs are nothing but your dual variables. I will show the dual formulation for transportation problem to next class, and so that how using duality we were able to come up with such a nice solution, which is much easier than your regular simplex. Just imagine solving a transportation problem using all the artificial variables and all the kind of calculation you were required to do. In that respect, it is much easier. You agree? Okay, thank you guys. I will see you on Wednesday. Also, there will be a industry speaker presentation next week on Friday. Okay, guys, if you do not have any questions, let's go for lunch. Bye-bye. Take care.
Thank you, sir.
Thank you, sir.
Thank you, guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.